Hello everyone. In this lesson we're going to take a look at analyzing and sketching graphs. In this section we're not really worried about equations. Instead we're trying to interpret what graphs mean or, given a situation, graph a representation of that situation. And we do this a lot in science. We use graphs to make sense of data and interpret what's going on. It's also happening a lot in the news right now, and we'll get to that problem at the end. So we're going to start with this. It says draw a graph that represents the following situation. You go shopping. You buy a shirt and spend half of your money. You meet a friend who owes you a quarter of the amount of money you have left and pays you back, and you buy lunch with the rest of your money. So what we're interested in is your money and how your money is changing with time. And so whenever we draw a graph, we do have to label and scale. Well, we don't necessarily have to scale. We have to label our axes so we know what's going on. So now down here we have time, and over here we have money. Now this is our y variable because it's on the y-axis, and this is our x variable. It's on the x-axis. And we see that money depends on time. This depends on when in the day we saw how much money you had. If we look after you went shopping and before your friend paid you back, you're going to have different amounts of money. So the amount of money you have depends on the time of the day we measure it. So you go shopping, you buy a shirt and spend half of your money. So let's say you started with this total amount of money up here. I don't know how much that is. I'm not going to put numbers on it. Numbers is what I mean when I say scale a graph. So you start with that much money, and you have that much money for some point in time. And then you buy a shirt and spend half your money. So after you buy a shirt, your money drops, and now it's down here. And it hangs out there for a while. But then you meet a friend who owes you a quarter of the amount of money you have left and pays you back. So you have this much money left, right? So this is $0. This is the total cash you started with. They owe you a quarter of that money back. So you're going to go up just a little bit, and you're going to hang out there. And then you buy lunch with the rest of your money. So you go down to 0. And so what this graph shows us is first you had some money. Then you had half of that money. Then you got some more money back, and then you spend all of your money, and you end with $0. So this shows how your money changes in time. Not all graphs are going to be straight lines. There are going to be sections like this. You might have curves. So we'll look at a couple examples. But this one, we're going to go the other way. It says describe the relationship between the two quantities. So here we have a car, and the car is got a speed versus time graph. And so we're seeing how the speed changes with time. And you'll notice this graph has 1, 2, 3, 4, 5 distinct sections on it. So I've got to have 5 different things that I'm describing. In this first section, section 1, the speed is increasing. And all I can say is it speeds up. And I can tell that because this is the origin, right? That's 0, and then at the end of section 1, it's faster. That took some time. Now, so this is non-zero. Let's call it 10. Doesn't matter. From this next bit, the car is moving at a constant speed. 2, constant speed. And then on section 3, it speeds up again. Now, I want to mention something. On this section it sped up, and on this section it sped up, but it sped up at a constant rate. And what I mean by that is it got a little bit faster, got faster by the same amount each time, right? These are straight lines. If you had a graph that looked like this and got steeper as it went on, you would see that it was getting faster, but between these two sections it got faster by this much. But then if I do that same time interval again, it got faster by this much. It got faster. This would be speeding up at an increasing rate. This is speeding up at a constant rate. So speed up at constant rate. This is also speeding up at a constant rate. And then we have 4, where it's not speeding up anymore. It's just moving at a constant speed. And then on 5, it is slowing down until it stops. Slow to stop, and again at a constant rate. And a constant rate just means that it's linear, right? It's a straight line. If it's a changing rate, then we don't get a straight line, we get a curve. Here is sales, and this is dollars versus time. So we can see dollars went up, so on sales, so sold product quickly, I'm going to say, and then that takes care of section 1. So we have lots of dollars coming in because we're selling lots of product. And then section 2, this little bit of it, no sales. And I say that because we didn't get any more dollars. Time was going on, but we didn't make any more money, so we must not have sold anything. And then section 3, we're going to sell product, but this time I'm going to say slowly. And the reason I say slowly is because this is not very fast. So here we sold something that was either very valuable or we sold lots of stuff because we got a lot of money in a hurry. Here we got some money, but it took a while. So we were selling stuff, but it was occurring slowly. So when you describe a graph, you've got to not only say what's changing, but also how is it changing? Is it changing at a constant rate? Is it changing slowly? Is it changing quickly? Is it getting faster? So we'll look at a couple of those. For instance, here's some temperature throughout the day in 2 different cities. This I'm going to split in half. So Belfast, Maine over here, I guess a couple different states, the temperature was increasing, but it was increasing at a decreasing rate. And what I mean by that is right here the temperature is getting warmer, warmer, warmer. And if this had continued at that speed, by the time we got to here, it'd been up here. But it didn't continue increasing at that same rate, right? It started to increase at a slower rate. So it didn't get all the way up to here. It only made it up to here. So I'm going to say temp increased at a decreasing rate. But then check this out. Over here, the temperature starts to go down. Now, if it had started here, it would be going down fairly slowly, and at the end of the day, it would only be this cold. But it got all the way down to here because now, as we move along this curve gets steeper and steeper and steeper. So the temp increased at a decreasing rate, and then the temp decreased at an increasing rate. Now, all you've got to think about on whether something is increasing or decreasing is the rate increasing or decreasing? Is the graph getting steeper or is the graph getting less steep? Here, the graph is getting less steep, less steep, less steep. So it's increasing because it is going up, but it's doing that at a decreasing rate because it's getting less steep. And now that it's decreasing because it's going down, but it's decreasing at an increasing rate because that graph is getting steeper. Over here, we don't have changing rates. Over here, we have straight lines. So these are constant rates. So again, I'm going to label this, here's section 1, here's section 2, here's section 3. On section 1, temp decreased at constant rate. And I'm going to say a fast constant rate because that's a steep line. And then 2, constant temp, right? Whatever that temperature is, it never changed. It stayed that temperature for that whole time interval. And then on section 3, the temp increased, but now it did this at a slow constant rate. And I say slow because that line is not very steep. It's only going up a little bit each time. I believe this is our last example. Sketch a graph that represents each situation. A stopped subway train gains speed at a constant rate until it reaches maximum speed. So I'm going to graph, and over here I'm going to put speed because that's what's changing, and it's changing with time. Let me switch color so we can actually see the graph. It says a stopped train gains speed at a constant rate. Constant rate tells me that I'm going to draw a straight line. Constant means straight. Stopped means it gets to start at 0. So it gains speed at a constant rate. It got faster at a constant rate until it reaches its maximum speed. It travels at this speed for a while, so now its speed stops changing. It's just moving at a constant rate, and then slows at a constant rate until coming to a stop. So it's got to get slower, but a constant rate again, and it ends at stop. So constant means straight line. B, on the other hand, is a little bit different. B says as the television size increases, the price increases at an increasing rate. So over here I'm going to have size. Nope, not what we have. It says as size increases, the price increases. So the price depends on the size. And so our independent variable is size, it's our x variable. Our dependent variable is price. Price depends on size. And it says this one, the price increases at an increasing rate. So that means as the size increases, the price goes up gradually and then faster, 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 faster. So I get this nice curve on that line. And now the last thing I want to look at is the current events. You guys have probably heard about flattening the curve and why we're social distancing. This graph right here is just for Nebraska, and it shows new cases by day. It doesn't show total cases, it shows new cases. So let's say we have cases of COVID-19, number of cases, and down here we have time. And at the beginning of this we had 0. And you can see that we got we got 60 new cases, we got 50 new cases, we got 40 new cases. So for this little bit of section right in here, every day we got about 40 to 60 new cases. So it was going up at a fairly constant rate. And then you can see here we're getting lots more new cases. And so it's going up and we're getting higher and higher and higher, right? Until now we've got 500 new cases on April 30th. Right, so the total number of cases is increasing, and this is not the goal. Our goal is so that the rate's increasing at a decreasing rate, so the curve gets flatter. And that's what we mean when we say flatten the curve. It's not that we're trying to prevent any new cases. We're trying to prevent the spread from becoming so rapid that it overwhelms the medical system. And so we're not doing a good job of flattening the curve right now. We're getting lots of new cases and the number of cases is increasing. And we want that to increase at a decreasing rate instead of increase at an increasing rate.